Okay, we got the parts done. Now we're going to work on the fixture that I designed up here. And basically it is a 2.5 inch by, I believe, 3 inches I went. 2.5 this way. This way, I'm pretty sure it was 3. 3.5. Let me give it a scale here. I don't know if I printed this this per scale or not. Let's see if I did. Looks like it. Looks like this is per scale. Real close anyway. And yeah, this was 3 inches. 3 inches long. So what I need, and then this is a tooling ball here. That tooling ball will go on both sides. That way when I tip it up at an angle, I can dial in the tooling ball and get to my valve guide holes and pockets. So I don't know, it's not showing an insert. So a lot of these engines end up with a brass insert, but this one here is running on the aluminum, so I'm hoping it'll be okay. It should be. I've got other engines that I run that way, that run it right off of the, I run the valve right off of the aluminum, and it seems to hold up, seems to be fine. So the first thing I want to do, I could make it a little longer. Thickness isn't going to matter. I can make it 1 inch thick, 2 inches thick, or whatever, because it'll be clamped up against the knee. You know, the knee will be sitting on this side, and there'll be a clamping, a couple clamps maybe, clamping it up against the knee when we go in here to do the valve guides. And then we'll flip it over, and then we do the same thing here. We flip it over, and we flip it so that this is straight up and down, and we dial in the tooling ball, and we move over 740 or 714 thou, and we drill the hole. That's probably what I'll do first, is this side. And I'm thinking about doing it on NC, as far as I don't have a hollow mill, and I could turn my boring head, turn the boring bar around backwards and do it, but then you're plunging with that down into this cavity, and I don't know if I really want to do that. The hollow mills work fine for doing finishing a diameter, but it's not so good for actually just plunging in. So what I think I'm going to do is set it up on the NC machine and generate that valve stem guide on both sides, there and there. So I'll tip it up like that, dial it in, then I know where they're at. I can just take the parts in and out. Same thing with this way. What's clamping the part is you put the part in the diameter hole that I have through this, put a parallel across it, push it up against it so it's tight, so that this side is flush with this, and then there's a bolt that goes through here. It's not showing it, but it's a 1/4 inch bolt, goes through here and clamps that. So I need to go ahead and make this little fixture, shop aid, holding fixture or whatever. And then plus I can also use it for generating these diameters in the back here. So So I might just do those over on the NC also. There's 2 diameters here, and then I'll have to clamp them in the lathe and finish that angle. Well, first thing off, find material for a holding fixture. So I'll be back when I have some material lined up and squared up and we're ready to start actually making the holding fixture. I'll be back. Okay, I had some material laying here that I already picked out for that holding fixture. So we're going to go ahead and square it up, and then we'll be in business. I'm going to take these parts, the pucks, cylinder heads, 6 of them. It's not a 6-cylinder. Radial engines have to be odd number of cylinders. Reason is the firing order on them is every other cylinder. So if you have an even number, it would never get to the it would never get to all the cylinders. You know, like if you've got 1, 2, 3, 4, and 5. The firing order is 1, 3, 5, and then it skips the 1, 2, skips the 3, 4, and it's back to 1, 3, so that it's every other cylinder that fires. I don't know, I mean, you guys probably already knew that. Anyway, let's square up this block and quit jabbering. And I'm looking for my, there they are, looking for my parallels. And now I'm looking for my brush. There it is. All right, we want to square this up pretty good so that it's nice and square. Nice and square with the world. Okay, so we'll set it in there like this. Then I'm going to clean this up on this side. Some of these chips off of there. Plus, I have a little piece of rod that I use for clamping so that that's up square with the back jaw. I don't have to tighten it up tight, just, yeah, I know. I already did that once and crashed, not tightening it up tight enough, but I don't like over tightening stuff. That actually wouldn't hurt anything, I guess. Yeah, I'm not going to worry about cleaning that up. I'm not going to worry about cleaning that up. It doesn't matter. It's not going to hurt nothing. So now, the side we just milled, we're going to put to the back. So we need some parallels to at least one. That's 2. And that's too short. What if I go like that? I want to keep as much of the down in the vise as I can so that I can use that surface to make sure it's square. And yeah, that'll work. So we're going to just go like that. Make sure this is clean. Set it down on there. Put this in there. Just want to make sure it's down on the parallels in the back. All right, we're just going to take a light skim cut on it. We're not going to take a whole lot. We'll come down and touch. And just crank her up about 10 thou is all. And we'll see if it cleans up. All right. Now what we're going to do is we're going to flip 180 this way. Still keeping the side that first side we milled against the jaw. Now I want to tap it a little bit. I'm just making sure that that is down on the parallels straight this way. And we're going to crank her up about 10 thou again. And then we'll take it over the surface. Well, I was thinking about taking it over the surface plate and checking it to make sure. And I think I will. All right, wipe the sides. I'm going to go over to the surface plate. See if I can line you up over here. I just want to check, make sure it's flat. Too much stuff in the way here. Let's take this one, put it over here, and take our little one that we got, and lock it. Put on the 0 in that corner. That's not good. We're at 0 here, and we get over here, 2. 2 plus. Then we go to 1.5 minus, and then we go 4 minus. So, try that again. We don't want it to be that far out. Let's go ahead. We know that this is the second surface here. I'm going to go ahead and mill. We kind of jumped where we shouldn't have, but that should have been our second surface right there, our third surface. And that's what we'll do now. The reason I did that is now we can clamp it and tap it down on parallels. Making sure there's no hang-ups on it. All right. And get the other parallel like this. Let's wipe this out. I feel a little bit of a, must have dropped something right there in the vise. It's got a bit of a, little bit of a, had a little bit of a mark right there. Let's do both sides. When I got these vices, they were really bad. They were from China. They're a China knockoff. And they did a horrible job at grinding them. I took them all apart where I worked and went ahead and ground everything on them. On it, and so, all right. Snug that down. All right. Where's the black magic marker? Whoop! Just about fell on my butt. Yeah, I know. You're looking at the wall now, or at the feed, or. All right. I'm just going to take and. Just scribble. I could have sprayed some Dykem on it too. I'm going to come up, come over. I'm going to come down and touch. Take it off of there. And I'm going to crank up about 5 thou. I'm going to cut in the same direction this time. It's definitely cleaning it all up. Now we'll see what we got. It feels nice and there's no mismatches or anything in it at all. Right? You're just looking at the back of the Raisinette anyway, so. But zero? Oh yeah, 0 across. Half a thou to that end. Half a thou. So it's a half a thou is the worst I could get. Good deal. All right. So that's good. Oh, I should probably check that. The other sides. Just to make sure. Because we really want that perpendicular to that, to the edges. So, what I'm going to do is I'm going to go clamp it onto a knee that I know is square, and then check. Back over there. The knee is still sitting there. I'm going to move this out of the way. And move these out of the way. Cylinders. Put them over here before they get knocked on the floor. Alright. Clamp. I want a clamp and I want a pin or a parallel. Yep. One clamp ought to do it. Short spot drill I got here. I'm going to put that underneath it. And clamp that up to the knee. Come up in top and pick it up and see where we're at. Zero. Looks like about half a thou there also. I can live with that. That'll be fine. All right, cool. We're in business. Because when I come to milling that, this long side will be clamped up against the knee like that. And then it'll be tipped. So we want to put that side to the back. And I don't need the tall parallels, I'll put these short ones in there. I'm going to tap it right here. That's good. All right. Now I designed that for it to be in center, but it doesn't have to be. It was supposed to be 3 inches long, and we've got it 3.5, so a 1/4 inch more. Yeah, so I'll still put it in the center. Even though these sides haven't been milled, it doesn't matter. Am I ever going to use those sides for anything? Nope. The sides are never going to mean nothing. It's just the sides here and these and there. So I'm going to go ahead and, oh, wait a minute. Sides will mean something. Spark plug hole. Spark plug hole has to be tilted the opposite way, so, and come off of the tooling. So it's not getting tilted. It's not getting tilted this way, it's getting tilted this way. See, these get tilted this way. And this one over here gets tilted from the end. So I do have to make sure the ends are cleaned up. So, with that said, let's put 3/4 inch head mill in there and clean up the edges. Dimension wise, it doesn't matter as long as I got room for a 1/4 inch screw to tighten up. End mill. I got some slow spiral end mills here. These are ones that I've sharpened. All right. I'm going to get to the other side, the back side here, and then I'm going to crank it in 10 thou, and then I'm just going to take it slow across there. Clean that up nice. Where's my arrows? Oh! Now, well, that's a nice finish. Almost a grind finish. There we go. Now we'll do the same thing to the other side. Down. Up a little bit. A little touch there, then I'm going to take 10. And go across it slow and easy. Then after that we'll set up and we'll bore the big hole and then punch in the hole for the tooling ball. Which reminds me, I hope I got a tooling ball that's a ½ inch. In height wise, from center line to the top. I'll show you what I mean here. Oh yes, beautiful. All right, let's just knock a little bit of a sharp edge off. And then I'm going to look in my tooling balls, see what I got. Perfect. All right. And what do I got? Got one with a 5/16 diameter. Here's a 1/4 inch. Here's another 1/4 inch. What I'm looking for is one with a ½ inch from the center line of the ball to the bottom. Because that's what I've dimensioned it with. And that's what this one is, a ½ inch tooling ball. So, and that'll, when we put the part in here and clamp it in, this tooling ball will be sitting here. And when we tip it up, we just take the dimension from that tooling ball, we dial that tooling ball in, and then we can, you'll see. I have a variety of them. Sometimes when I was working, I had to have like, I had to have like 2 or 3 of them, so I've got a few of them, different ones. It depends on the designer, tool designer, at what they put in. And as a practice, I always put in a ½ inch one. 1/2 inch tooling ball height.